Okay. Well, I redid my video so I could make a better one. The last video was kind of boring. This one's part 1, the speed of light and gravity. Well, the speed of light actually goes about the speed of gravity. Here we can start, and I'll tell you the speed of gravity and the speed of light in a second. Less than a second. More than a second, I mean. Sir Isaac Newton thought that the speed of gravity was instantaneous, and Einstein assumed it traveled the speed of light. Well, the answer is that the speed of gravity, one of the fundamental constants of nature, they found that gravity does move at the same speed of light, and there is actually a figure. Their actual figure was 1.6 times the speed of light. That's actually faster than the speed of light. But there was an error in a plus or minus of 0.21, so it could be faster, it could be slower. The results was then announced at 2002. I'll tell you that. I'll post that website on this. If you haven't noticed that light and gravity are about the same speed, who's to say that light isn't faster outside the realm of gravity? The sun's gravitational orbit stops at approximately 50 light years, which I like to call gravity years because they're about the same. Because the gravitational pull... Hold on. Let me restart. The sun's gravitational orbit stops at approximately 50 light years. Because the gravitational pull around us... Because of the gravitational pull around us, how can light ever go its full speed? If you think about it, the sun is one huge thing. A photon is very, very small, and big things like little things, and the photon is one of the smallest things in the universe, and the sun is a very, 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 very huge thing. Not big for a star, but it's huge in itself, so the gravity should affect the photon a lot. Well, remember, light is a pushing force. Gravity is a pulling force. So light and gravity are almost opposites. So at the same time, light is pushing out from the sun's gravity, which is pulling back, to a point where light is under the speed of gravity just barely. Remember that they found that gravity does move the same as the speed of light. Their actual figure was 1.06 times the speed of light. And it cannot exceed the speed of gravity because gravity pulls everything. To exceed the speed of gravity is to exceed its pull, which does not happen. The black hole proves this. However, there's a loophole. Light passes by it and the black hole utterly sucks it in. Therefore, light must be under the speed of gravity. Or simply put, it would, and if it weren't, it would escape it. Now, I mean under the speed of gravity as in when it's under gravity. If it was faster than the speed of gravity waves, it would escape it. If it's slower than the speed of gravity waves, it wouldn't, and that's while it's in the realm of gravity. Sorry for that conclusion. But since it does not escape a black hole under the speed of gravity which acts like a speed limit. However, but since it doesn't escape a black hole under the speed of gravity which acts like a speed limit, however, doesn't this prove that gamma rays which escape black holes exceed the speed of gravity? Yes, it must. Through the logical conclusion I just made, it must. Gamma rays must be faster than the speed of gravity, which is about the speed of light. Therefore, if gamma rays are faster than the speed of gravity, they are much, much more faster than the speed of gravity. So therefore, light is faster than gravity and must be, unless it's under the gravitational force. But not until enough of it is built up to exceed the power of the gravitational pull. That's how you get a gamma ray. You have a lot of light built up in one little area, one little space, and then it exceeds the gravitational pull of the black hole and creates a gamma ray. That is my own assumed knowledge, which I get from some of it's based off of other science and stuff. Small light generated by the sun goes under the speed of gravity because even though light is faster than the speed of gravity proven by gamma rays, it is still under its pull proven by black holes. So light is traveling at a much shorter pace in a gravitational field than not in one. Don't forget about magnetic fields. They could slow down light as well. This is part of the theory. This part of the theory is mine. So theoretically, since light can escape black holes through gamma rays, but not in its normal form, such as sun rays, light has an infinite speed. Part of light is energy. Literally, doesn't this mean that light is eternal also? If it keeps going and does not stop, not even after it forms the biggest laser beam that's ever been seen, a gamma ray, therefore light is instantaneous without the effect of gravity or magnetic fields. Basically what I'm saying is that light at its strongest power, which is a gamma ray, is instantaneous. Light at its weakest power, which is sunlight, is also instantaneous, but with the effects of gravity, it only goes the speed of gravity, or a little less than the speed of gravity, because of the pull. Now you got to remember, the pull on a photon compared to a sun is huge. So without the sun, with the sun, you need the sun to have light, but without the sun's gravity, that photon would go much faster than that. About multiply the difference between the sun and that photon. I don't think we can mathematically do that at this point, but multiply that, and you probably get whatever figure that comes out of that. Multiply that by the speed of light, and that's the true speed of light without a gravitational pull, which is instantaneous. Because it has that speed has to be so fast, it's unbelievable. So the speed of light is actually the speed of light times the speed of light, probably, which is extremely fast. That is astronomically faster, because the photon is being pulled by the sun, which is so much bigger than the photon. That's just like the gamma ray pushing out from because the gravitational pull of the black hole is so big, it pulls in light, which is one of the weakest but strongest forms in the universe, just like water. Water is very weak, but is very strong. When you ice. Ice is very weak, but is very strong. When you have ice in its smallest form, it is very, very weak, but when you freeze it, you can freeze it actually harder than a diamond. Same thing with light. Light at its weakest form doesn't affect much, but at its strongest form can destroy everything, including black holes. I think if a gamma ray was directed at a black hole, it's my theoretical possibility that gamma ray would actually wipe out that black hole, based on how much power is in that gamma ray, based on how much energy is in one proton of light. Because apparently light can go extremely fast without a gravitational field. Now, of course, there's a gravitational field all around the galaxy. There has to be. But even if you escape the sun's gravity, you immensely go instantaneous. Not already go instantaneous. If you escape the Milky Way's gravity, you definitely go really fast. This would explain why the galaxies all around us are so much faster than the speed of light. Why they are expanding so much faster than the speed of light. Not expanding, I would say going away. So much faster than the speed of light. They don't have gravity pulling them in. So they can go as fast, just instantaneous through their whole lifetime away. It wouldn't. So we're actually stuck in our galaxy because, unless we escape our galaxy and we find out how to use the power of light to go twice as fast as the power of a galaxy, it is just extreme. It is extreme how fast the speed of light truly is. Not the speed of gravity, which I just explained to you. Light and the speed of gravity, according to science, is the same, but the speed of light without gravity. That is extreme. Let me multiply that real quick. I'm going to multiply that for you real quick. Just real quick.